Hey everybody. So to me overall, the concept of geometry as it relates to AI has become like as mainstream as it can be as anything relates to AI overall. And then within that, kind of like my whole overarching goal when it comes to these things is to stay like ahead of the competition and to be looking towards the like new directions and the next directions that people are underestimating or not looking towards within this. That's kind of my goal that I set for myself within this, just with my understanding of AI and the space overall and everything as it relates to it overall today. And so within that, the big thing to me that is like the big question that everyone focuses on is AI, and it has been focusing on for the last 3 years is AI agents, right? Like over and over again. It's a concept, and I've made a lot of videos on it overall. But here I am coming back to that problem again, and just like everyone else. And then uh, within that, though, I do have unique opinions and a unique framework that I've developed around this, and I've hardened around this. And it's actually like it's a framework that I developed this like 3 years ago. Like I had this concept, and then it was like a base concept that I had, but I realized it was like very costly, and I didn't know how to develop it or frame it out or build it out in any way overall, which was this concept of like software for AI was kind of how I envisioned it at the time. And then uh, within that, and as it relates to AI agents, so to me, the biggest thing and the biggest problem that I distilled down when it comes to AI agents, as it is currently known right now, is a problem of execution and not in planning, right? And then so that's been proven all throughout. I made a few videos on that throughout this channel, and on this channel very specifically with the research papers. I think it was MIT very specifically that or it was someone very big that proved that out that it's not a planning problem, it's an execution problem. I think 90% sure it was MIT. And then so within that and around that, to me, it seems that everyone is still tackling these problems the wrong way, right? Because it's let's throw like 50 different agents at it. Let's make sure that the agents can think about these problems for a long time, etc. Right? But all of those tackle the planning problem, and then when you look at the planning, the models get and they score very high accuracy when it comes to the planning. It's the execution phase where they lack and where they're lacking in. And then uh, to me, like what would be the ultimate solution to this problem would be to create like a CRM world, like flat out, right? Like essentially, like the model's entire existence is, and it's like its world model is a like a back end system of of an enterprise system, right? And then like that's the ideal solution to this problem overall, right? Like that's the ultimate dream goal within that. And then so just kind of distilling that down and then into something that is like real world and can actually like be tested and measured within that, which could then be scaled up, right? Because scaling laws showcase that all of this uh, would, if it works small, it will work big within this. And then I can showcase that it does work small within this and showcase this framework that I've created overall within this and with that overall concept in mind, right? Essentially, that like um, world model of in this instance, like a back end for a company is really what this all boils down to, right? And then within that, I create the machine world layer. And then here's a direct link to the collab notebook, which I'll go over here in a second. But for the last few years, the conversation around AI agents has been stuck in the wrong place. People keep asking, how do we make models reason better? How do we get them to follow instructions more reliably? How do we prompt them into acting rationally in dynamic environments? But the core issue's never been the model. The issue is the execution layer, the substrate that turns intent into actions. and ensures that those actions change the real world correctly. Like, so the intention isn't that the model can't think about the problem properly, it's that it can't execute on the problem properly. And then so right now we're asking AI to operate inside systems built for humans, right? Like, so the big problem that they have, why can't they execute? Because these systems, the internet, computers, all software, every thing that exists on the planet is built for a human operating system for how humans think, takes into account all of the assumptions that are just they come readily to a human, right? And then so all of those stack up into big problems within this. And then so right now, we're asking AI to operate inside of these systems, just flat out built for humans, right? And then so systems designed around the limits of human memory, human attention, human error, human tolerance, and human UX affordances. We built the modern software stack for ourselves. Then we asked, and we've been asking, a non-human intelligence to adapt to it, and that's the mistake, right? What I built instead is a world layer shaped for AI itself, where the world is represented in a machine legible declarative state. Actions are described by contracts with explicit preconditions and effects, and the execution layer handles retry logic, consistency, and failure recovery. And it's the framework is three steps, and these three concepts, right? Where it's you have a world, you have contracts, and you have an execution layer. And then so the world is the broad level, the contracts are what exactly the model wants to or needs to execute on, and then the execution layer on is whether or not that execution was successful or not, is basically how that frames down. And I'll dive deeper into that, right? But so the model only does one thing, and then so in that instance it chooses the next action to attempt. And then so that's the thing, right? Like, you're taking away the decision making and the processes from the LLM model that wouldn't actually occur within like the like mind part of the like thinking process within this for a human, right? But we ask LLM models to do that and fill that in, and then to me that's where that execution failure comes in. And so I call this architecture overall MWL, or the machine world layer. And then just before we dive deeper into this, how is this not MCP or a model context protocol? The big thing to me, I'll summarize this whole entire section if you want to read through this, right? But so to me, when it comes to the differences between MCP and MWL, what I'm proposing here is MCP is essentially a creation of a big toolbox, right? And then so you create a toolbox, and then you create a bunch of tools that fit within the toolbox, and then you tell the model, okay, if you this is your toolbox, and you train it, and this is a toolbox that exists, and then if you want to access the internet, then you access the internet tool from your toolbox, and then here's a standardized way that we train all models to do that overall, right? And then so that's a very clear and straightforward concept in and of itself. Whereas what MWL says is that your toolbox is a world, is a universe, is the latent space that you operate within, right? And very literally in one particular aspect of this, right? And then the toolbox is a sidecar in this instance, so it's quite literally a latent space world for the model, right? And then within that, it's that framing is different. Rather than like, here's an external toolbox that you access, it's here's a tool world that you have access to, and then that the tool world is essentially operates like, we'll call it your central nervous system, as well as your prefrontal frontal cortex, right? So it's gonna like offload some of the tasks and some of the heavy lifting for you, and allow for you to unify your understanding of this world and operate within it in essentially like the same way that like a human intelligence would, is like the exact architecture of it, right? And then so the key insight is that human software is built around human cognitive limitations. It's built around step-by-step UI flows, menus and dashboards, procedural documentation, and implicit workflow knowledge. And then we need those structures because humans forget, right? Like that's the biggest part of being a human, is that like we like even if you have the knowledge embedded in there, you forget things a lot, right? And I do all the time. And then so that's why we need these very like step by step linear processes, right? That's how we've built out computers, software, etc. from the beginning, very specifically because humans have these very specific limitations. And then so everything about the UI itself is built out around these limitations. And then so our current process is we just have the models scan this UI that is built out around all of these processes, and then we just say, hey, Derpy, like go through and like figure it out and make it work, right? Like and do that. But it's like it's not built off of these processes, right? Like models don't think that way. They're not built that way. They're built different, right? So forcing AI to operate in human-shaped workflows means that the models must infer state that should be explicit, guess preconditions it cannot verify, recreate business logic that should be formalized, shoulder the burden of every error recovery that software should handle, right? And then like we put all these things together, and then the result of it is that we get hallucinations, loops, and broken states. And then the big one is that it works on the demo app, but not in reality. Like that's the biggest one of this all, right? And then all of this comes together, and then we say it's a failure of the model. But no, it's not like the model is not the failure, and it's been proven up and down within that, right? Because if the model was the failure, it would be a failure in the planning phase. But like all of the research, I don't need to back that statement up at this point because I've like looked at all of the videos that I've made on this channel from like every institution on the planet that backs it up at this point. That the problem is. With the execution and not with the planning, right? So if the problem is with the execution and not the planning, that means that the models aren't failing at their jobs. We're just giving them too much of a job, right? And then so it's not a reasoning failure; it's a world design failure. We're telling them to like once you have your plan figured out, then you have to operate within this UI flow that's built 100% for humans. And then they're like, and they fall apart, and then we're like, oh, you're stupid. And then that's how that goes overall. And then so the MWL architecture in simple terms. MWL breaks the world into three machine stable components: layer roles designed for world model, declarative state of reality, AI contracts, which are actions with preconditions and effects, and the AI execution engine, which is a safe application of effects with retries and verification of reality. And then so it's these three layers again: the world model, AI contracts, and the AI execution engine, right? And then so the world model overall is like the declarative class of like to me again it's like a CRM system, right? That's the perfect example where it's like the world model can be any of your objects, and then so it's the highest level object, and then so an object could be users, it could be invoices, it could be orders, opportunities, leads, contacts, etc. Right? And then like all of these are concepts that exist at the world level and at the world concept level. So within that, then you have contracts, which are actions that you can perform with world model declarative states, right? So with users, you can perform a contract to update a user record, right? With invoices, you can perform a contract to pay an invoice, etc. And then so within that and controlling and governing that is an execution engine. And then so if you have failures within that, the execution engine determines like what is your path for those failures. Is it a critical failure? Is it like something small? What's the guidance for the next step that you should take within that, essentially? And then so the execution engine very specific. Like so the bottom line is that the model only decides what to try next, right? You strip out every other aspect of it except for the model's decision. Every decision it's faced with is what do we do next? What do you do next? What do you do next? And then so the execution engine checks if the action is allowed, executes it through the appropriate driver, retries transient failures safely, detects permanent failures and blocks unsafe paths, verifies effects actually occurred in the world, and refreshes a state and continues the loop. And so there are frameworks that I've seen that they build this into their framework overall. Like they have this execution framework within it. The bottom line and the difference that I see in the failure within that I see is that they're relying on the LLM to be this execution engine, right? And then so this framework is very specifically not like you don't put three LLMs together, one of them being the world model, one of them being the AI contracts, and one of them being the execution engine. That's not how it works at all, right? All of this is a framework that exists 100% independent of and doesn't actually require an LLM model. And then so this entire framework exists outside of and bolts onto on top of the LLM model is the major difference within that, right? So you're not training three models to do this. You're taking this framework and then you're either bolting it onto an LLM model or you're not. And then so this produces a feedback stable closed loop where the loop becomes 1, observe the world, then 2, choose the next action, 3, execute through contracts, 4, verify results, and then 5, repeat. And that's essentially the world that the model lives in, the world that it begins to understand, and how it actually executes actions within that. And the bottom line within that and what that allows for is that there's no hallucination paths that exist within this, right? There's no ability for the model to hallucinate within these steps because it's the steps and the world are set up in a deterministic way within that. And it has deterministic checks and balances that exist outside of the model, right? Again, this whole entire framework exists outside of the LLM model. So it's not inside of it, right? There's no a bit like the LLM model can't hallucinate this because it exists as an external layer from the model, externally from the model, right? And then so within that, sidecars are the missing piece within that everyone else ignores that is putting this together. So instead of retraining giant models to learn business logic, MWL attaches sidecar neural model modules, which are tiny classifiers, risk scores, and prioritization heuristics. These act like reflex pathways within and while the LLM remains the cortex itself. So in regards towards a component analogy, the cortex is your abstract reasoning, the sidecar is your spinal and your autonomic reflexes, and the execution engine is your like nervous system, right? Your sensory feedback. So this mirrors biological intelligence and it works for the same reason it works in biology. Not everything should go through thinking. Why this matters overall? Most agent research tries to improve the model. MWL improves the world that the model acts inside. That's the breakthrough. Models today are already strong enough to operate autonomously. They just don't have a stable substrate to operate in. It's an execution problem and not a planning problem. Therefore, if it's an execution problem, it means that it's not a problem with the model. The model is executing properly. It's a problem with the world. And then so we need to change that world for the model and then create a world model that is proper for the world model to execute within. And that's all I'm doing within this. And then so if you give them one and they stop behaving like toys and they start behaving like agents. As far as a one sentence summary, MWL does not try to make AI act more like humans. It makes the world act in a way that AI can operate more reliably. That's a shift. And once you see it, you can't unsee it, right? It's pretty simple overall to me. And then so within this, proving this out, here's the code that for my testing that I did within this. And I performed a multitude of tests before this, right? I just wanted to make this a more robust test. So this is the MWL with a sidecar plus execution engine. And then this is just the test suite here. where so essentially in this example I'm creating a contracts world, right? And then so within contracts world there exists contracts for invoices, like the type of the type of contract that the model can enter into is invoices, whether or not to pay an invoice. And then so all of the execution parameters for the model then are built around whether or not the model should be, can be, and can safely, in this instance, pay these invoices. And then so in this example state, I have two invoices here, right? One for $242.89 and one for $51. And they're from supplier ABC and supplier XYZ. And then so essentially I build out the contracts here and build out the invoices. So these are the contracts and the invoices that exist within invoice world in this instance, right? And then so this is essentially all of this data is all the data that makes up invoice world and then is a part of invoice world in this instance, right? And then from that, I then create just a bunch of synthetic data off of that, and then I create the model. And I train the model on the synthetic data, and then as we can see, like as expected for me from in this, after about like 7 epochs, we're getting up to 97-98% accuracy on it overall, which is exactly where I want it to be. And then from here, we're adding on bolting on those so we have like our brain, and then we have our prefrontal cortex, and then we need to add like the brain stem and then the central nervous system, right? And then so this is adding like the brain stem, right? And then this is adding the central nervous system with the Sidecar inference helpers. And then this is like essentially the full logic and full nervous system itself, right? So all of the drivers, the executors, etc. And then so this has the most logic. Within this, so this is important to lay within this, right? Like so the streaming execution, like the bottom line within this is that this needs to operate like a world for the model, right? So the model's getting this and processing this as a streaming task as it goes through, right? Like it's executing actions like in steps, like so step 1, 2, 3, 4 in a sequence. And then so it needs to have that data streamed in that way. And then so that's part of its processing and just building out part of the framework that operates and exists around the model, making sure that it's getting that data in a streaming format, right? And then I just perform a quick demo within it, and then the quick demo it comes out essentially perfect overall. It pays 41 invoices, it leaves 11 to final due, and then that's basically it. None of the major treks from the nervous system went in, and then here I just do essentially a big test overall, and then I print the top 15 results. And then in every single one of these that's printed, or the first 15, you can see it's 100% pass rate is what matters within this. But then there's a whole bunch of other numbers that you can look through and execute within this, right? And then so it's doing a bunch of logic, updating tables, etc., with 100% accuracy within this instance on this very robust test across a multitude of columns, rows, etc., right, and numbers that it needs to populate and do it within, with no hallucinations. Because then again, within this, the whole entire point of this is that the model itself isn't actually putting in the data, right? It's taking whatever data exists within, in this instance, invoice world, and then it's saying, so in invoice world, what is the current ID? And then the current ID would either be invoice 001 or 002. In invoice world, what is the current status of ID of invoice 001? It's due. What is the current status of invoice 002? It's paid, etc. Right? And it's just framing this in a completely different context and framing overall than it would for a human, right? Like none of this would make sense of like framing it in this kind of way, like to me, it wouldn't make sense overall for a human. Like I never thought of building out like a computer game that operates a computer that operates more like a game, right? For a human in this instance, specifically for like work type tasks. Like maybe the world would have been a better place overall if we had thought of these things better, right? If we made uh, invoice tasks like more like Legend of Zelda, they might be a lot more fun. We might have a lot more accountants in the world overall. I don't know if that'd be good or bad, but like, uh, it just framing it exactly how it is. But I've never had to think of it in these ways and frame these problems in these contexts overall because it's humans don't have the constraints, the built-in constraints as to how their logic processes and all of that works, that AI models do, that force me essentially to look into and think of these frameworks overall, right? And then so it's essentially like again, like humans have unique problems and different problems than AI has, and that's exactly why all of the everything related to computers is built around humans, right? The mouse that I have in my hand right now, the UI that we're looking at, like the invention of the UI itself, right? Like all of these inventions are made to make computers easier and easier to understand and manipulate for humans. Were not for AI, and it's like those are two different things and two different worlds. And then so if you have for 3 years people can't understand and figure out why exactly this execution problem exists for 3 years, and then nobody wants to look at that particular part of the equation, I wonder why, right? And so that's all I'm doing within this. And then so to me it's pretty simple, just reframing the question overall. And then this work. So again, like and highlighting so that like this code that we're looking at here, none of this is utilizing an LLM within any of this code, right? Like this sits on top of the LLM, and then so even without the LLM, you can see on like with this invoice world task, we're already getting perfect accuracy within it, right? Like so then all the LLM is doing is just saying like is what's the next decision within this given all of this data, and that the world is going to deterministically figure itself out via these rules that you build around it, and you just have the model just kind of like shoot through that basically, and then do what the model is good at in that particular instance and particular task, and then take care of automating all of this in like superhuman time and accuracy. And then so there it is overall. I'll leave a link to the article here, which has a link to the code that I went over there. And if you like this type of content, please like and subscribe. Thank you very much.